Assalamualaikum and hi everyone. So in this video, I'm going to explain to you about the different types of chemical reactions involving your organic compound. So there are four main reactions which consisting of addition reaction, substitution reaction, elimination and rearrangement. Okay, so for each of these cases, I'm going to give you a few examples, okay, for you to understand better about these types of reaction. But before we proceed with these types of reaction, I'm going to explain to you about nucleophiles and electrophiles. Okay, so nucleophile is commonly known as nucleus-loving atoms or groups or ion, whereas electrophile is referring to electron loving. Okay, so nucleophiles is seeking for a positively charged atoms or positively charged center. So that means this nucleophile is having an electron rich atoms or electron rich group. So commonly nucleophile referring to anion, electron rich group, or any atoms that has lone pair of electrons, because a nucleophile can donate that extra electrons to a positive center. Okay, so few examples of nucleophile, okay, such as chloride ion, bromide ion, iodide ion for the anions, whereas for the electron rich group are just like alkyl group. So examples of alkyl group including methyl, okay, ethyl and so on. Whereas a lone pair of electrons is referring to any atom that have lone pair of electron. For examples, if we have amino group, so amino is made up of nitrogen, and this nitrogen can either bond to hydrogen if it's an primary amine, so NH2, or it can be when it directly bond to another alkyl group. Okay, nitrogen always have lone pair of electron, and that lone pair of electron makes the amino group to be available as a nucleophile because it can donate that lone pair of electron. Okay, so electrophile is electron loving. That means it's seeking for electron. So indirectly it can tell you that electrophile has lack of electron or deficiency of electron. So normally electrophiles are cation such as H+, okay, that is a common one in your organic compound, whereas electron deficient group is like carbocation, okay, and incomplete atoms are just like in beryllium, boron and aluminium, because these three elements are special elements which can have incomplete octet arrangement. Okay, so first we're going to look at substitution reaction. So substitution reaction involving one or two more atoms in the organic compound is being replaced or is being substituted with another atoms. Okay, so there are three types of substitution reaction. Okay, so it's either nucleophilic or electrophilic or free radical substitution. Okay, so let's look at the first example here. Okay, so in this first example, okay, so this OH is being replaced by a chlorine. Okay, so it's present as chloride ion. So a chloride ion is an anion, so anion is a nucleophile. Therefore, in this one is a nucleophilic substitution reaction, because a nucleophile substituting the nucleophile that is present in your organic compound. Okay, so OH is a nucleophile, so this OH is being replaced with another nucleophile which is your chloride ion. Okay, so the second one, okay, so in the second example, as you can see, this is an alkene because it only consists of carbon and hydrogen. Okay, so in the presence of UV light and chlorine gas, okay, one of the hydrogens in the first carbon is being replaced with a chloride ion. Okay, so one of the H here is being replaced with a chlorine. Okay, so in this one, in the presence of a UV, that means it involving free radical, because alkane is inert or is chemically unreactive, so it's impossible to have a nucleophilic substitutions or electrophilic substitution. So the only way to allow your alkene to react is by giving UV light. So this UV radiation will initiate a homolytic cleavage to occur in one of the bonds in your alkene. So one of the hydrogens that is present in your alkene is being substituted with a chlorine atom. So this one we name it as free radical substitution. The hint how to identify is a free radical is when there is UV light present in your reaction. So let's move on to the third question. So in this one we have benzene ring reacting with a nitric acid. So one of the hydrogen here in your benzene ring is being replaced by NO2. So it's a substitution reaction, but in this one your benzene ring is a nucleophile. So benzene ring is a nucleophile, therefore this nucleophile will attract electrophile. So since it attracts electrophile, so this one it becomes electrophilic substitution reaction. So let's move on to an addition reaction. Alright, so let's move on to addition reaction. So addition reaction means we are adding atom to the organic compound. So the atom can be added either one or two or more. So this one is a common reaction with organic compound that have C double bond C or C double bond O. So or C triple bond C, which is in your alkyne. So addition reaction is the common reaction for compound with C double bond with double bond, such as in alkene or alkyne or carbonyl compound, like aldehyde or ketones. So the first example here is your alkene. So let's count the number of carbon and hydrogen that is initially present in your alkene. So we have 1, 2, 3, 4, 5. So 5 carbon and hydrogen 5, 6, 7 is 10 hydrogen. After reacting this alkene with HCl or your hydrochloric acid, so we are making a new compound which has so we are making a new compound with single bond. So the HCl is being added to the C double bond C, and now we have extra atoms in your organic compound. So if initially we only have 5 carbon and 10 hydrogen, now we have 5 carbon with 11 hydrogen and 1 chlorine atom. So more atoms mean more atoms is present in your final product. So that means addition reaction is taking place. So so next you need to identify either this addition reaction is electrophilic addition reaction or nucleophilic addition reaction. By first we need to find out that this C double bond C in your alkene, is it a nucleophile or is it an electrophile center? So a C double bond C, this carbon-carbon double bond is an electron-rich group, electron-rich center. So that means your C double bond C is a nucleophilic center. Since this one is a nucleophilic center, so it will attract the opposite, which is electrophile. Therefore, in this one, it is an electrophilic addition reaction. So that means all alkenes will have electrophilic addition reaction by breaking that C double bond C and forming more bond with another atoms. Alright, so let's move on to the second example. So the second examples, I'm using ketones which has C double bond O. C double bond O is your carbonyl functional group. So in this one, please do remember about the difference in electronegativity will lead to polar molecules or polar bond. Okay, so in the C double bond O, your C is electropositive, is more electropositive compared to your oxygen. So therefore, this carbon will become partially positive, whereas your oxygen here in your C double bond O will be partially negative. Okay, so this carbon is partially positive. That means it is a center of positive side. We name it as electrophilic center. Okay, so for this addition reaction at C double bond O, it will attract the opposite molecule, which is it will attract a nucleophile. Okay, so this one, it is a nucleophilic addition reaction. Okay, so how to be sure about this is an addition reaction? Okay, as you can see in this reaction, okay, we have C double bond O, but in the final product, okay, so that C double bond O, the double bond is breaking, and we are substituting the Okay, how to be sure that this is an addition reaction at the carbonyl compound? Okay, so the double bond at your C double bond O is breaking and hydrogen is added to it. Okay, so this OH, okay, so hydrogen is added to the oxygen and another hydrogen is added to the carbon. So two hydrogen is being added to the carbonyl compound, resulting in a new product, okay, with more atoms. So let's count the number of atoms that is initially present in your reactants and let's compare it with the final product. So initially in the reactants we have 4 carbon, okay, and then 8 hydrogen and 1 oxygen atom. But in the final product we still have 4 carbon, but now we have extra 2 hydrogen, which is 10, and 1 oxygen. So we have more hydrogen present in your final product, so that means this one is an addition reaction, and it's a nucleophilic addition reaction because the C double bond O has electrophilic center and it will attract a nucleophile for addition reaction to take place. The final 2 types of reaction is rearrangement and elimination reaction. So let's look at the first example here. Okay, so I have here alcohol, and when alcohol reacting with concentrated sulfuric acid with the presence of heat, okay, this OH is being eliminated. Okay, OH and one of this hydrogen at this carbon, okay, is being eliminated and being secreted as water. Okay, so okay, if initially I have 5 carbon and then 4, 6, 12 hydrogen and 1 oxygen, okay, but in the final product I only have 5 carbon with 10 hydrogen and no oxygen. Okay, so from alcohol I'm forming an alkene. Okay, so some of the atoms in your alcohol is being eliminated as water molecule. So this one, it is an elimination reaction because we eliminate some of the atoms from the original reactants. Okay, the last example. Okay, so in this one I have ketone, and this ketone undergoes a rearrangement. Okay, so instead of having C double bond O, I'm making C double bond C. Okay, so it is not elimination or not addition or substitution. I call this reaction as rearrangement because, okay, we are changing the positions of the double bond. Instead of between C double bond O, now we are making it between C double bond C. There is no change in the number of atoms. Okay, just to be sure, let's count how many atoms that is present in your original reactants and in the final product. Okay, so in my original reactant I have 3 carbon with 6 hydrogen and 1 oxygen. Okay, in the final product I still have 3 carbon with 6 hydrogen and 1 oxygen. So there is no decrease in the number of atoms, no additions of the number of atoms, okay, and no replacement of another atom. So we still have the same number of atoms and the same types of atoms in the reactants and in the final product. So that means it's not addition, it's not substitution, it's not even elimination, but it is a rearrangement. Okay, so the formations of the double bond at a different position. Okay, so that's all for the types of reaction. Thank you.